All right, so on this problem, we are finding the accumulated value of an investment of $5,000 at 5% for 8 years. So we are looking at doing it in two ways. We're going to compound it monthly and then continuously, and we're going to figure out which one is the better way to go. So first thing we have to do is find the values that we have to plug into our formula. So we know our P, which is our principal. Our principal is $5,000. That's the money we're starting with. Now, as far as our rate is our percentage there. So our rate is going to be 0.05. And we want to write it as a decimal. We don't want to leave it as a percent value. And the final number that we need is going to be our value of the time. So when we're looking at the time, we're looking at t. So we can have our p is equal to 5,000. Our rate is equal to 0.05. Our t is equal to the amount of years here, so we have 8 years. And we have our n. N is how often it's compounded, and in this case it's compounded monthly. There's 12 months in a year, so we're using 12. So we're just going to plug it into our formula. So we're looking for the value of A. So A equals 5,000 times 1 plus our rate of 0.05 over n, which is 12, raised to the 12 times t, which is 8. We're going to plug that into our calculator, and as we do that, we're going to find that our accumulated value is equal to $7,452.93. So that's how much we would have at the end of 8 years. So that was part A. So that was the first one that we're doing. Now we need to do part B. So in part B, we're using continuously. So continuously, we're going to use our PERT formula that's right here. So we have our A is equal to our principal, which again is $5,000, times E to the R, which is 0.05, times T, which is 8. So with that value, when we plug this into our calculator, we will get A is equal to $7,459.12. So if we're comparing to see which one is better, they're both 7,450, but on our part B, we actually end up with 9 instead of 2. So the answer to part C will be that. Which is better? It will be continuously. Because we're getting more money on our return. So the next question that we have on regarding interest is if we're going to find out how long it takes a $3,500 investment to double if it is invested at 5% compounded monthly. So with this one, if you're in my class, we're doing something that's similar to question number 35. I just changed the values a little bit so it wasn't exactly the same. All right, so we again need to figure out what we have. We have P, and P in this case is $3,500. And we have our R, which is 5%, so that'll be 0.05. Now N, again here we are compounded monthly, so N will equal 12. And we don't have a time on this. It says how long. We're looking for T. So T is what we want to find. But it says that investments doubled. That would be the accumulated value. So A will be 3,500 times 2, which will equal 7,000. So that's what our goal is to get to. So if we use our formula of A equals P times 1 plus R over N raised to the NT, Our accumulated value is 7,000 equal to our principal of 3,500 times 1 plus our rate of 0.05 over 12 raised to the 12t. So to solve this, it's a little bit different than what we did before because we've got to solve this one in pieces. We can't just put it all in a calculator. So first thing I'm going to do is divide both sides by 3,500. We're going to simplify things down a little bit. Well, 7,000 divided by 3,500 is going to get us 2, which makes sense because we doubled it. And then we have our 1 plus 0.05 divided by 12 raised to 12t. Well, now we have to get the t down. Well, how can we do that? Well, if we take the natural log of both sides, then we're able to bring the 12t down in front. So we're going to take the natural log of 2 and the natural log of our parentheses. So this will get us ln of 2 is equal to the ln of 1 plus 0.05 divided by 12. And we're going to take our 12t and bring it down front. So we're moving our exponent. Well, now we've got our t out of our exponent so we can actually solve for it. So if we divide this side by 12, ln of 1 plus 0.05 divided by 12, and we do this to both sides, 12 ln 1 plus 0.05 divided by 12, we find that the natural log of 2 divided by 12 times the natural log of 1 plus 0.05 divided by 12 is equal to t. Now this we could go ahead and plug in our calculator. Just got to make sure you use your parentheses correctly. And we will find that t is approximately 13.8918. So we're going to say that t is 13.9. I'm going to kind of simplify it.